All right, here we go. Okay, so we're going to start on 10.1, which is the language of hypothesis testing. Okay, now, I think I told you that exam number 4 was the last easy test. They're going to get harder from here on. Okay, so let me first start with an example here, hopefully easy, is you bet on a coin flip. Okay, the coin comes up, tail, 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 tail. Is your friend cheating? Okay. Now, there's a few ways we could do this. We could figure this out directly. Sample size is rather small, right? So how would we do this normally? Well, how would we figure out the probability of getting 5 tails in a row? Right, so the probability of the first coin to be a tail would be 0.5, or rather, I'm going to write it as 1/2. Okay, the second one is also 1/2, 1/2, 1/2, 1/2, which is 2, 4, 8, 16, 32. 1 out of 32, which works out to be about 3% of the time. Okay? So what that means is, if you were to repeat this experiment 100 times, where you're flipping it 5 times, 100 times, okay, you would get 5 tails in a row 3 out of the 100 times. So is it possible to get 5 tails in a row? Yes. Is it likely to get 5 tails in a row? Okay. So typically, we're going to refer to our significance. Alpha equals our significance level is 5% of the time. Okay. So let's say that you say, you know what, this is so unlikely that I'm going to call you a cheater. Okay? Because it happens less than 5% of the time. Now, if we were to repeat this experiment 100 times, 97 times, if this came up tails 5 times in a row, I would be correct in calling you a cheater. And 3 times I would be wrong, that I would call you a cheater, but you were not cheating. Okay? So you can think of alpha as your significance level. Significance level. Okay? We'll talk about that in a minute. Okay? But that's a pretty good level. If you could be right 95 times out of 100, would you be happy with that score on my test? Yeah, that would be a nice score, right? Okay? And so your significance level of alpha is 0.5. This is the most common. Other common ones are alpha equals 0.01. Let's say you want to be right 99% of the time. Or maybe on a smaller sample size, your alpha might be 0.10. You're saying, well, I'm going to be right 90% of the time. Okay? Those are the most common. Now, you can choose whatever alpha that you want. When I was working at the University of Utah on a genetics study, they had a crazy alpha. Their alpha was 1 times 10 to the minus 16th. And do you realize how small that is? Okay. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, now the interesting thing about that is, you may say, why so small? Well, the problem is we've got so many genes. If you're doing a genetic study, if you used alpha as 0.05, you'd probably end up with a few hundred, maybe even 1,000 genes that might be associated with whatever disease you're trying to study. even with an alpha equal to this, okay, we would end up with 5 or 6 genes that might be associated with psoriasis or cancer or whatever you're studying. And so if you're doing a genetic study, this is actually the most common alpha. But for the rest of us, that's the most common one we're going to use, okay? All right, so, whoa, got out of focus there, I don't know why. Does that help? There we go, focus. All right, so let's bring up some other terms. Your null hypothesis is typically represented as an H sub 0, okay? It is a math statement that means there is no change, no difference, or a fair coin, okay? And it's assumed to be true unless we find evidence, okay? All right, I guess that's it. I might add some more stuff later. Oh, you know what, I'm gonna add another one. It always, maybe I should, no, I'm not gonna say almost always has an equal sign, okay? So something equals something, okay? Actually, let me throw one more out here. It's always about the population parameter, okay? All right, let's talk about the alternative hypothesis. Alternative hypothesis, okay? Now, depending on your book, it will either use H sub 1 or H sub A. I'm happy with either one, it doesn't matter, okay? In fact, you'll see me interchange them. It doesn't mean anything other than it's not the null, okay? And this is a statement we are trying to prove, okay? It has a less than, a greater than, or a not equal to. We'll talk about that in just a minute, okay? And also, it's always about population parameter, okay? All right, so let's talk about the types of tests, okay? Types of hypothesis tests. Number one, we have a two-tailed, okay? So typically, you're going to have something like a null hypothesis where you're going to have a parameter equal to some value, okay? And your null hypothesis will be the parameter does not equal some value, okay? So that's what we would call a two-tailed test, okay? So this is something you're going to want to identify. Number two, we're going to do a left-tailed test, okay? Your null hypothesis is going to be parameter, and maybe, by the way, we should probably, well, I'll say that in a second. Parameter equals some sort of a value, okay? Whereas the alternative hypothesis is going to be the parameter is less than some value. Okay? We could also do what's called a right-tailed test. Okay? The null is still the parameter equals some value. Your alternative is going to be the parameter is greater than some value. Okay? So the main difference is you're looking at this symbol here on the alternative hypothesis. You'll see that the parameter is the same on all the null hypothesis in every case. Okay? So it's only the alternative hypothesis that's going to change. Does that make sense? Okay, so the nice thing about today's homework is you're not going to need a calculator. There are no calculations. Okay? And in fact, let me just say this. These are some good skills to learn in today's chapter. Tomorrow, I'm going to give you an outline for the next 4 chapters. Okay? But today we're going to concentrate mainly on, can you find the null and the alternative hypothesis, and is it one or two-tailed? Okay? So let me give you an example here. Okay, so in fact, maybe we should go back to that coin flip. Well, that's all right. I'll do this one. A pharmaceutical company has a new antibiotic for kids. Other similar antibiotics show 2% have side effects. Okay? FDA wants to know if the new drug has more than 2% side effects. Find the null and the alternative hypothesis. Okay. All right, and I'm going to go with, well, let's see here. Okay, so Chase, I'm going to pick on you first. Lucky. Okay, so just as a reminder, the null hypothesis is a math statement that means no change, no difference, or a fair coin. It's assumed to be true unless we find evidence otherwise. Almost always has an equal sign, and it's always about the population parameter. So I'm going to help you out here. You're going to have to find some sort of a math statement that has an equal sign in it. And what equals what?
I guess I would assume that you would say like the similar antibiotics equals like 2%.
2%. Okay? I'm going to write 2% as 0.02. Okay? Now, I want to concentrate on this one here, always about the population parameter. So conceptually, what you said was true, but I don't want to write a sentence. Okay? I want to write a letter equals 2%. So what letter should I pick? Pick P? Why did you pick P?
P always represents the population.
Because P always represents the population proportion. Okay? Does that make sense? Okay? All right. So now that Chase did so well on that, we're going to pick on Juan. Can you come up with an alternative hypothesis? Just as a reminder, alternative hypothesis is a statement we are trying to prove. It has a less than, a greater than, or a not equal sign, and it's always also about the population parameter. So whatever we picked on the first one, whatever letter we picked, we're going to pick again on the second one. So I'll help you out. There's going to be a P in your alternative hypothesis. Now, is it going to be less than, greater than, or not equal to, and why?
Greater than 2%.
Greater than 2% because?
We want to know if the new drug has more than 2% side effects.
More than 2%, that's the key phrase there. Okay? Well done. All right. So this is going to be your homework. Now, is this a one or a two-tailed test? A one-tailed, and is it a right or a left-tailed test? It's going to be a right-tailed test because we're going greater than, right? So this is right-tailed. Okay? That's going to mean more in a future section, but for now, I just want you to identify what kind of a test it is. Okay? So this is what the homework is going to be, basically. Okay? Let's do another one. Blue book value of a Chevy Corvette is $37,500. Okay? Grant wants to know if the price is different in Miami. Find the null and the alternative hypothesis. Okay? So Jordan, let's pick on you first.
So it would be
P equals 37,500. Who agrees with Jordan? 1, 2, 3, 4. Who disagrees? No, nobody? You should have disagreed. He was close. But is this a population proportion? Is $37,500 a proportion? It's not, is it? So he picked the wrong letter. What's a letter? What letter should he have picked? What do you think, Eric? X bar or mu, which one? Which one is the population parameter? Mu, right? X bar is not a parameter, it's a statistic, right? From a sample. So we should use mu, okay? So Shelby, what do you think the alternative hypothesis is?
Mu does not equal 37,000.
Mu is not equal to 37,500, and you said not equal because?
Because he wants to know if it's different.
Yeah, the price is different, doesn't tell you higher or lower, does it? Okay, so this is a one or a two-tailed test. It's going to be a two-tailed. Okay? All right. Do a couple more really quick here. How about standard deviation of a 64-ounce bottle of detergent is 0.23 ounces. Company gets new machine and wants to know if less variability. Okay? The null hypothesis, the alternative hypothesis. What do you think, Josh?
Sigma equals 0.2.
0.23, and you picked sigma because standard deviation, the alternative.
S less than.
No, you got to use the same letter.
Sigma is less than 0.2.
Sigma less than 0.23. So this is what kind of a test? Left-tailed. Okay. All right. Finally, the last thing I want to talk about is type 1 and 2 errors. Okay. Now, let's talk about reality. And we're going to say that the null is true versus the alternative is true. And we're going to talk about your conclusion. The null, we're going to say, do not reject, or we're going to say reject the null. Okay? We never use what I'm going to refer to as the A word, accept. You never accept anything. Okay? Going back to that coin problem, you could accuse me of cheating and I wasn't cheating, right? Okay? So the reality is, the null could be true, you could not reject the null, and that would be a correct decision. Or conversely, the alternative was true, you reject the null, and that would also be a correct conclusion. But there's two mistakes you could make. The alternative could be true, but you don't reject the null. Okay, that's known as a type 2 error, and we use the letter beta. Or it could be that the null is true, but you reject the null. That's what we call a type 1 error, and that's what we refer to as alpha. Okay? Now, really quickly, because I know we're out of time, this is the better error to make. Let me give you a quick example. Let's say that, go back to that pharmaceutical company problem, okay? We're trying to determine if this drug is safe. The type 1 error is we believe that P is greater than 0.02 when P equals 0.02 or less. Okay? We think the drug is unsafe when it really was safe. Okay? So that's one mistake we could make. The type 2 error is we believe P equals 0.02 when P is greater than 0.02. Okay? The type 2 error says we think it's safe, but it's not safe. Okay? So which mistake would you rather make? Would you rather keep the drug off the market and not make money, or would you rather put the drug on the market and then get sued? Okay? Typically, the type 1 error is what we do. Okay? That's what we refer, that's the one we would prefer, that's our alpha. Okay? That's what we refer to as our significance level. So, that's all I have today. We'll see you tomorrow. Quiz will be on 10.1. Have a great day.